Welcome to LabMinutes.com. Now that we have a good understanding of the twice NAT and the object NAT from our previous video, in this video we're going to kind of combine it together and look at the bigger picture and how we can use that in real life. Right now you know that the ASA version 8.3 and later we are dealing with a NAT table that's partitioned to 3 different sections. So if you look at the diagram, there are section 1, 2, and 3. Section 1 being used by the twice NAT, section 2 for object NAT, and section 3 is for the twice NAT again with the after auto keyword. And you have a complete freedom to put your NAT statements in any order you want. But again, the source matching will always go from top to bottom, so it's always a good idea to put a more specific NAT statement on the top and then the least specific at the bottom, as you see it indicated by the green arrow here. But if you look back at the pre-8.3 version of the ASA, that process is kind of taken care of for you by the ASA based on the concept of the order of NAT precedence. So it's depending on what kind of NATs you have configured on the ASA kind of figure it out for you what needs to, or what NAT statement is matched by the traffic, going by the most specific type of NAT. So if you look through our list here, usually it goes by this particular order. So starting off with, you have a NAT exemption with the NAT 0 access list that is usually get evaluated first, and then if you have a identity NAT, and again this depends on how specific you have your IP subnet defined. So identity NAT is basically a static NAT, so that might come later in the order. It's just depend on your NAT statement. Then it follows by the policy static PAT and policy static NAT with the static command and the access list tied to it. And then you have the regular static PAT and static NAT. And then you have all the dynamic NAT starting with the policy dynamic NAT, dynamic NATs, policy PAT, and the regular PAT. And at the end, if you have a Nat Control turned on, then the translation will be enforced. So if you don't have anything matched by other NAT statements, the traffic will be dropped by the ASA. Now, so in terms of the migration strategy, you might understand a little easier, or it's actually work out better for you if you want to maintain that same concept of the pre-8.3 with putting the more specific type of NAT first. So by mapping the list of pre-8.3 NAT types to our post-8.3, you can see it kind of maps out pretty nicely. And I'm just showing the one that's in red is the one that's you're dealing with the policy type of NAT. So that is kind of determining factor of where you, or which section of the NAT table you're going to put your NAT statement into, because for those policy static or policy NAT, you are dealing with a condition based on not just the source but also the destination, and the only type of NAT and the 8.3 version that's capable of supporting that is the twice NAT. So you can see the red writings that we have here, it can only be mapped to basically section 1 or 3 where the twice NAT is being used. So without those, if you do not do any kind of policy NAT at all, then you have a complete freedom as far as where you want to place your other types of NAT in. It can go into any other section. But if you have those policy NAT in place, then this is probably what you need. So in this particular lab video, we're not going to be concentrating at the syntax of the command. We're just going to go through and configure the different types of NAT and see how it actually works as far as the source NAT and especially its destination NAT that we'll see later, and how that behave differently depending on the location that you put your destination NAT. So our lab setup is pretty much the same as the previous video with twice NAT and the object NAT, but now I already have the config kind of prepared for you already. So we're just going to go from top to bottom real quick. We're going to start off with the NAT exemption, and you will use a lot of these if you deal with things like a user VPN, or even a LAN-to-LAN type of VPN where you do not want to perform a source NAT when the traffic goes to a certain destination, being your remote user VPN or remote VPN site. So here we have a NAT exemption that's based on an IP that's conditioned on the IP address 3333, and we're just gonna do you're just not going to perform any kind of NAT, so the IP stays the same. Then we have the identity NAT. So let me move this to the side so you can see. We have the identity NAT that we're going to put up at the top for the IP 3245, and we do not have any kind of condition on the destination. It's just going to NAT it to itself. Next we have a static path. The same kind of static path that we dealt with the previous lab, with mapping the TCP port 2323 to the telnet port for the IP 32.37, and having the mapped IP of 1.1.1.37. Next we have a static NAT. As you can see, I'm just putting this in the exact same order that we are showing here on the diagram. So for the static NAT, we kind of as in the static path, these are all in section 2 now. Just to want to point that out. So start using the object network with the NAT inside the object. So this is an object NAT. With the static NAT, 1-to-1 NAT of 3232 to 132. And then we have dynamic NAT that we at this time just placed in the section 3 of the twice NAT. So you can see the after auto keyword with the sourced dynamic, and we're just matching or natting IP range 96 through 98 for the map IP with the real IP of 32.39. Okay, and then the last kind type of NAT that we're gonna put in is the PAT. So we have two test IP 41 and 43 that's going to be padded to a single IP of 1.1.1.128. Okay, so feel free to pause the video and review the config and make sure you understand what we're about to put into the firewall before proceeding. But for us here, we're just going to go ahead and copy and paste these statements. Okay, I'm just going to do one section at a time, make sure there's no errors. Okay, identity NAT, static path, static NAT, dynamic NAT, and last we have a regular path. Okay, so all of those are now in. Let's take a look at config, show NAT. And here we can see the config has gone into each relevant sections. Okay, so now let's start doing some ping tests just to make sure that everything is working. From the switch run in the back, we have various loopback interface IPs that we can use to source our ping or our test. So first, let's start off with our static. Let's see, it's a NAT exemption, and on R2 we're gonna run debug IP ICMP so we can see what IP is coming from, or the R2 seeing is coming from. So ping, first we're going to do our NAT exemption, conditioning on IP 3333, sourcing from loopback 0. Okay, and R2 is seeing that's coming from 32.32, which is our loopback 0. Do show NAT, and you see translate hit 1. That's good. Let's keep going. So ping. Next, we're going to test our. Let's see, what do we have after that exemption? Identity NAT. So .45, and that's loopback 6. So ping 111 1, sourcing loopback 6. And since it's identity NAT, we should be seeing the real IP coming across. So 32.45, so that's also working. Next, from R2, we're going to test our static PAT. We're going to do telnet to 111.37, which is the mapped IP for that telnet service. And the IP is 2323, this TCP port rather. So we got the password prompt, and we're dropped into switch 1. So our port forwarding works correctly. Next one, we're going to do a regular static NAT. So just ping 1111, sourcing loopback 0, and the ping succeeded. And R2 seeing the IP is coming from the the mapped IP of 11132. So static IP, or static NAT, is verify. Next, we're going to do dynamic NAT. Here we're going to ping 1111 again, sourcing from loopback 3. Okay, so that works, and R2 is seeing the IP coming from 111.98. Since this is dynamic NAT, let's try to clear, just to show we have show xlate. Let's see right here, 32.39 is mapped to 111.98. So clear xlate, and we initiate a ping again. Since it's doing dynamic NAT, it should grab the IP, or the next IP from the pool. And it did, which is 111.97. Okay, and our pool was 96 through 98, so we know it's working. Okay, and the last type of NAT is PAT, and our test IP is .41, which is loopback 4, I believe. Okay. And that is padded to 111.128 like we configured. Okay, so verify that all of our NATs are working. The next thing we're going to do, we're going to start playing around with it a little bit and kind of get a better understanding of how it behaves. The first thing we're going to test, the one that we have not yet tested, is the NAT control. So right now we have not configured any kind of NAT control. And in fact, with the 8.3 version of the ASA, the exact command of NAT-control is no longer available as it was in the pre-8.3. So following the same rule here, the NAT control is basically like a catch-all. So if there's no explicit match on your NAT configuration, it's just going to resort to the NAT control and see if it's whether or not it's defined in the pre-8.3. So just to basically emulate that or simulate that same kind of behavior on the version 8.3, which is going to be putting like a catch-all statement at the bottom just to get that NAT control behavior. But just to show you that, to test the NAT control, let's do show run NAT real quick on firewall 1. Okay, we're going to pick this one, the identity NAT for the 32.45 as our test. So you can see 32.45 is not matching anything. It's not matching any other NAT statements. So if you remove that, we basically bypass the NAT for the 32.45 IPs. And if you try to ping 1111 sourcing from loopback, let's see, 45, I believe is loopback 6. You can see it's coming through as the real IP, and if you do show xlate and look at 32.45, you can see there's no entry in the NAT table. So what happened was the ASA is trying to match the source IP through the NAT configuration and did not find anything. It just filed off the table, so no NAT was performed for that particular IP. Now I want to say, if you want, for security reason, and actually having a better control understanding of your the traffic in your network, you might want to put a NAT control at the bottom and say anything that we have not explicitly defined for our NAT, we do not want it to pass through the ASA, so we want it to be dropped. So what we're going to do, we're going to configure a equivalent of a NAT control. So on firewall 1, you come up with an object network, and you give it a mapped IP of all 0. And then to make sure that the statement goes at the bottom of your NAT table, it has to go into section 3. So inside, outside, after, source, dynamic, any, and then we're gonna map. Actually, the source is matched right here, so that host IP is your mapped IP that we're gonna utilize. So what the statement says is anything that's matching, or it's actually everything that's it doesn't get matched by the explicit NAT statements will be matched by this particular statement, and the mapped IP that you're mapped or you're natted the traffic to is all 0. So it's like a catch-all or a black hole type of statement. So once you apply that and you go back to switch 1 and then you do the ping again, you can see in R2 we are not receiving any kind of traffic. So if you go back to firewall 1 and do show NAT, you can see a translated hit of 5. Although the match happens, it gets natted to somewhat useless IPs. Okay, so that's how you enforce a NAT control on the ASA version 8.3. But before I forget, let's put that statement we took out back, which is right here. And if you go back to switch 1, since we have explicitly defined the NAT for that 32.45 IPs, now the traffic was able to pass through the ASA no problem. Okay, so next we're going to look at policy NAT. So let's say you have a new requirement that says the IP of 32.45 needs to be able to ping 3333 and having a source natted to an IP, say 111.45. So based on that requirement, you come back and look at the NAT table and see if there are existing match already. So you can see here our first NAT exemption says if you're coming from 172.16.32/24 subnet going to 3333, you would not be natted. So in order to override that, you need to come up with a more specific statement. So you can see it kind of breaks this rule a little bit, where it said static NAT comes after that exemption. It's basically going to depend on your requirement, and whether or not what you need is more basically have to go by the order of what's being more specific as far as the IP goes. So in order to achieve the result that we want, we're first gonna go configure object network, and we chose the mapped IP of 111.45, host 111.45. And since we know that this particular NAT statement has to overwrite the NAT exception that we have configured earlier, so the order has to be has to come before 1, so you have to basically put in the order in the command. And here said you want this particular statement to go in line number 1. You go source static, and we already have the real IP 172.1632.45 defined, and it's going to get mapped to 111.45 with a destination static, and this is conditioning on the 3333 IP. Okay, so now we go back and do show run here. You see the new statement took the place of the NAT exemption being in order 1. And going back to the switch, you ping 3333, sourcing from loopback 6. Okay, let's see why I said host unreachable sent. Oh, that's because we have not configured loopback. So let's do loopback 1 IP address. Let's try that again, and the ping went through successfully. See, the R2 is seeing the traffic coming from 111.45. I do show NAT, and you can see translate hits right there. Okay, so the order is very important, and you need to pick your order wisely and make sure it doesn't get caught by the other NAT statement that comes before that. Okay, so next we're going to turn our attention to a destination NAT and see how that behaves, and what happens if you put that in different sections with a destination NAT. So here we're going to translate 2222, that's on the outside IPs, to 172.16.96.32, that's the inside IPs. So first we're going to need to create object network. Let me show you the template that I have ready, just to kind of get things moving along faster. Okay, so we have a mapped IP of the object network defined, and object network the real IP defined as well. So I'm going to copy that, paste. So the first thing we're going to try is we're going to put the destination NAT right at the bottom of the NAT table, just to see how that might work. So that would be NAT inside, outside. Make sure you go after source static any. So we're just gonna NAT it to itself, the source IP, but for the destination static we're gonna do mapped and then real. Okay, let's see. I would assume it's the destination. There you go. And if you look at show NAT, it goes right at the bottom of the NAT table, even after our so-called NAT control. Okay. So let's see what happens if you're trying to ping 172.16.96.32, sourcing from loopback 0. Okay, of course it fails. But somehow R2 is receiving the ping packets and the source IP is not being translated. So let's see how that works. Come back and look at the NAT table. You would have thought that since we have a 172.16.32.32 defined, so let's do maybe the show run NAT might kind of look. Okay, there you go. So since we have the 172.16.32.32 defined in section 2 being natted to 111.32, you might have thought that that might, going from top to bottom, that would get matched first. Well, it doesn't really work that way. So when you're talking about destination NAT, and you can see more clearly if we do a packet tracer. And also I want to show you when you show NAT, you can see although this rules right here that we put in is right at the bottom, it still gets matched. And it doesn't really match the one that we have in the section 2. So to show you why, we need to look at the packet tracer. And input, coming from inside, we're just going to use ICMP for our test. Coming from 3232, TCP type 8, subtype 0. Going to 172.16.96.32. Okay, let's just fast forward to the bottom and then scroll up and take a look. So here, it's the packet tracer kind of walks you through the steps of the processing that happens in the ASA. The first thing is look at the access list, which we did not have, and it's allowed by default from the inside. The next action that the ASA took was actually unnat. So we're trying to unnat any destination IPs that it finds matching the NAT statements. Since we define the destination NAT in the NAT table, despite the fact that it's at the bottom of the NAT table, we still get matched first. So as you can see here, it untranslate the 96.32 to 2222. So the destination NAT actually happens before the source NAT. So once that happens, although you can see, although it match, it doesn't really make sense here because you see in step number 6, the source IP kind of matches the object network NAT that we defined in section 2, but the static translate, it said it doesn't really perform any translation, although in object network in section 2 that we defined for static NAT, we know it worked because we tested it earlier. But just the fact that, you know, the destination NAT gets performed already, it's kind of bent the rule a little bit, or it changed the rules. So it's just go ahead and actually use the statement that you have for the source NAT, which is any in this case, so it doesn't really get translate to anything. And that's why we saw the IP came through to R2 untranslated. Okay. So let's go ahead and remove that. Okay, for our next test, we're going to take the source NAT out of the equation altogether. So instead, we're going to do something like this. So what we do is just do a destination NAT only, and we do that by reversing the order of the interface. So we do not do inside outside anymore. We're just going to do NAT outside inside, and now we can define the IP being a source and without having a destination IP defined. So we're going to go ahead and do a NAT coming from outside to the inside, having the real source IP 2222 getting mapped to 172.16.96.32, and we're going to put that in the section 1 at the bottom of section 1 and see what kind of results we get. Okay, so we do that and we ping from switch 1. We get the exact same results. Okay, And if we do show NAT, you can see there's one untranslate hits to our NAT configuration we just put in. Let's go back to the packet tracer and see what it looks like. There you go. Here in the packet tracer, and again, same thing happens. So the unnat was performed first, and if the IP was able to get untranslated correctly from 96.32 to 2.2, and that's reflected earlier on the translate hits that we saw in the NAT table. And since we did not have the source NAT defined for the source IP 32.32, you can see it doesn't, although it matches again the section 2 object network, it doesn't really do anything to it. Okay, so that doesn't really work neither, doing it that way. Okay, so let's move on to the next test, and let's remove what we put in right here. The next test is going to be, we're going to do a destination NAT in section 2. So we're going to be putting in object network destination NAT with the real IP 2222 and the map IP that we have already defined earlier with 96.32. Since it's an object NAT, it's going to go into section 2, show NAT. Okay, and automatically, like we talked about earlier in the previous object NAT video, section 2 gets reordered automatically by the ASA. So that we put the destination NAT in after the first two rules that we put. It gets put into the first order by the ASA. So now going to the switch 1, and we do a ping. And look at that, the ping works. And the source gets translated correctly to 111.32. Okay, and you show NAT. And right there you can see the translated hit is 5. So we know it got matched to that particular rule. And if you do the packet tracer, step through that. With the unnat, gets performed first correctly. And when it comes to the actual source NAT, it matched the section 2 rule, and you can see the source 32.32 gets translated correctly to 1.32. Okay, let's go back and look at the NAT table. And the reason why that works, because 172.16.32.32 doesn't actually get matched at all in section 1. You can see none of these rule matches that particular source IP. So once it hits section 2, if you remember from our previous video object NATs, section 2 allows the source and destination IP to be translated independently from from two different independent rules. So the first rule for us here is the destination NAT, which gets matched and performed. And at the same time, the ASA comes back and say, hey, do we have another rule that we can use to translate the source? Which we do right here. Okay. The same thing wasn't true earlier when we put the destination only NAT only destination only NAT in section 1. Once that gets matched, it doesn't even bother looking at the other sections. So this is a unique characteristic of section 2. However, if you have that defined, the destination NAT defined section 2, but your IP 172.16.32.32 source IP happens to get matched by something in section 1, that would not work either. So both source and destination NATs needs to be present in section 2. Okay, and again, just to show you that, we can do a ping to that IP, sourcing from loopback 6, and that's the 32.45 that we have defined up here, just to show you that separate translation of the source and the destination does not work when the two rules are in different section. You can see the IP comes through natively, but if you look at show NAT, this actually doesn't really use that rule number 3 here in section 1. And if you do packet tracer, and then it's IP45, see the unnat was performed, but for the source, it matches the NAT statement in section 1, but nothing is actually happened there. Okay, so what would you do if you need to do a destination NAT, or if the IP of your source happens to match one of the rule that's already in section 1? In that case, the only option you have is to come up with a more specific rule and put that on top of the rule that's existing rules. So for us, we can try to do things something like NAT in out, and let's put it on the first order. Source dynamic. If you said, okay, it doesn't really matter what source IP gets translated to when it tries to talk to 2222, then we can just do dynamic any interface, and then destination static, and can do map 172.1696.32 real 2222 show NAT. The rule gets put on top of everything, and if we go back to switch 1 and perform the exact same ping, you can see it worked just fine. And it gets the source IP gets natted to the ASA outside IPs. Okay, there you go. But if you want to keep the same kind of source address translation as the one that you already have, you would need to come up with a more specific rule for each of those type of the source address that you have. So here you can see that as long as you only deal with the source NAT, it's kind of straightforward in the configuration, but as soon as you add the destination, you can see where you put those statements actually matters. And as your NAT table gets larger, you might need to look twice and make sure what you put in is going to result in what you expect. Okay, so that wraps up our video on NAT of the ASA 8.3 migration strategy. Thank you for watching LabMinutes.com. I'll see you guys in the next